Hello, my name is Mr. Schoolman, and this is a quick introduction to rational functions. Rational function essentially makes up a fraction where you have a polynomial on top of a polynomial. And the only condition is that the denominator polynomial is not equal to 0. Now, f of x equals 1 over x is your parent function. It's your basic rational function, and this is a graph of f of x equals 1 over x. We have a few other examples of rational functions, negative 3 over x, 2x minus 5 over the quantity x minus 1, 9 over x plus 4, or you can have this polynomial, this quadratic over this quadratic, and you get interesting shapes. You get what are called horizontal asymptotes, vertical asymptotes, holes. You want to look at interesting critical values such as x-intercepts, y-intercepts, and much more. Now, how do we get this shape? Why does it kind of get close to 0 and seem to take off in the positive direction, and on the negative side axis it goes in a negative direction as it approaches 0? And why does it approach the x-axis as x gets bigger or x gets very small? Well, if you look at a table and you look at small numbers, as x from negative 1 and from 1, as it approaches 0 and gets closer and closer to 0, we can see that 1, the function 1 over x, as 1 over this gets really small, y gets really large. So from the negative side, you get, approaching infinity, and from the positive side, you get going up to positive infinity. Likewise, if we look at as you move away from the y-axis, as x gets very large or x gets very small, these numbers as your denominator make y just do the opposite. So as x gets really big, y gets closer and closer to 0. As x gets really big, y gets closer and closer to 0. And it's all because of that property of rational functions, 1 over x. Next thing we can look at is, if we're looking at, you want to look at the domain of a rational function 1 over the quantity x minus 2. You want to be able to describe the parts of the graph, what's interesting about this rational function. So as before, we were centered around the origin. Now we're centered around 2. Now why is that? 1 over x minus 2 kind of shifts everything over to the right 2. If we look at the graph, this is the same graph, 1 over x minus 2. If we look at the table here, we can see at 2 it's undefined, because when x is 2, 2 minus 2 is 0, and anything divided by 0 would give you an undefined number. And as we can see, moving the table here, as we go in a negative direction by 1/100ths, it gets smaller and smaller and smaller and smaller as it starts approaching. When you get close to 10, it gets really close to 0 on the negative side. So what we're doing is we're following the graph right here. Now if we go the other direction, positive on the x-axis, we can see that it gets, let's see, there we go. So right at 2, it starts at 100, and then as our x gets bigger and bigger, this, you can see, gets smaller and smaller, and it starts approaching, getting closer and closer to 0 the more we go. The next thing I want to show you is, if you remember with quadratics, I have my quadratic equation a times x minus h squared plus k. The same properties of transformations work for all functions. So if we move a, or let's move h, so that gives us the right and left shift, as we can see. Okay, if we move k, it goes up and down. And if we change our scale factor, as x gets larger, our parabola dilates vertically, and when it goes negative, it concaves down, and so on. So let's look at the same thing with our function here. Now I put in some other letters just not to be confused with the previous page on this document. So I use b as the scale factor, d as my right and left shift, and e as my up and down. So if I move d, x minus d, it has the same effect. It moves it right and left. If I move outside the function part, or the rational expression, if I add e, oops, go this way, it goes up, goes down, we can see that. And likewise, if b gets bigger, it dilates, it's vertical stretch, and what happens when it gets negative? It reflects over the x-axis. So it behaves the same as what we saw with parabolas and other functions as well. So I can move this over here, I can move this up, and I could reflect it over right there and dilate it. And hopefully this gives you a good sense of how rational functions work, why we have this basic shape of a rational function, and we'll continue on later on. Thank you very much.